Okay, this is section 4, again sine formula and cosine formula. First of all, let's check the answer for question 23 and 24 that I gave you in the last section 3. So, the answer is this. So in the last section, we have learned two formulae for cosine formula. The first one is c squared equal to a squared plus b squared minus 2ab cosine c. We will use it when we have SAS, sine angle sine. The second one is cosine c equal to a squared plus b squared minus c squared over 2ab. We will use it when we have three sines, SSS. So today we will go through some examples by using cosine formula, and sometimes we will use sine formula. So question 1, we see triangle ABC. So you are given two adjacent sides and the included angle. You are asked to find these opposite sides BC and correct your answer to 1 decimal place. So in this case, you can see we have sine, angle, sine. They must be adjacent, okay? Sine and sine, they must be adjacent, and included angle is between these two lines, so SAS. So if we, in this case, SAS, we can use cosine formula. So let us memorize the cosine formula, which is c squared equals to a squared plus b squared minus 2ab cosine c. We can use this formula to find the side c. So in this case, which one is a? So you don't have to look at all this symbol. So actually, what is ABC? ABC is just in a triangle. This one is A, this one is B, and this is angle C. So if they are SAS, then equals angle C equals A equals B. In the same case, this angle is angle C. This one is A, this one is B. Okay, this one is A, this one is B, this one is angle C. So we can now use this formula. So how to do this? So in this case, the side C is just BC. So BC squared equals to AC squared plus AB squared minus 2AC cosine angle CAB. Sorry, no space. Okay. So BC squared is equal to AC squared, 20x squared plus BAB squared, 40 squared. Okay. The two adjacent sides, the square of these two sides, and sum them up, and then minus 2, 28, 40, and cosine the included angle. The included angle is 35. So we write 35. Okay? So the opposite side, BC squared, is this size, the square of this size plus this size, square of this size, and then minus 2AB cosine C. Okay? Therefore, BC is the square root of this. So after you use the calculator to calculate, the answer is 23.4 cm, correct to 1 dp. Okay, we go to the next question. So this question asks you to find the parameter of the quadrilateral ABCD, this four-side polygon. Okay, you are given these three sides, these two angles. So in order to find the parameter means find all the sides of this polygon. So we have this one, but not this one. So what we need to do is to find the length of CD. Okay. So how to find CD? Okay, we can see in triangle ABD there are SAS, sine angle sine. So if it is sine angle sine SAS, we can use cosine formula to find the opposite side BD. After that, in triangle BDC, we have this side, this angle, and this side. Again, this is SAS. So if it is the case SAS, we can again use cosine formula to find the opposite side. That means we can find all the sides of this quadrilateral, and then we can find the parameter. Okay, so first of all, we should look at triangle ABD and use cosine formula. So the opposite side is BD. BD squared equals to 10 squared plus 12 squared minus 2, 10, 12, cosine 135 degrees. Okay, so after using a calculator to calculate, we can have 20.340 cm, correct to 3 dp. So in this question, you are asked to give 1 dp. However, before we get the final answer, please use more digits. For example, in this case, we take 3 dp instead of 1 dp only to avoid getting error on your answer. Okay, so we take more digits. So after we can find this line, we can consider this triangle and find this line. So we consider triangle DCB. So because we have these two sides and this angle, we want to find CD. So we write CD square. Remember the right hand square, okay? CD square is just this side square. So this side square is copy from here, 20.340 square plus 18 square minus 2, the first line, the second line, cosine to include the angle. Okay, so we can get CD as 13.296 cm, correct to 3 dp. Again, take more decimal places. Okay, therefore the parameter of the quadrilateral ABCD is AB plus BC plus CD plus AD, that is 10 plus 12 plus 18 plus 13.296. So the answer is 53.3 cm, correct to 1 dp. Finished. And then we go to the third example. This case is a bit different from the previous two examples. This one you are given three sides, all sides of the triangle. The question asks you to find the value of all angles of triangle ABC. Okay, all angles. So, we know that the longer the side, the bigger the angle. So, which angle we should find first? It doesn't matter. You can find the largest angle corresponding to 7, the longest length, which is the biggest angle, or you can find the smallest angle, or you just can find this angle. It doesn't matter. So in this example, I will find the biggest angle first, or you can try to find angle B and angle A first by yourself, and the answer is the same. Okay, so we want to find angle C. So if we want to find angle C, we use which formula, which is cosine C equals to a squared plus b squared minus c squared over 2ab. Okay, so if we want to find this angle, which one is this one is C, so which one is side C? So C is the side opposite to this angle. So the angle we want to find opposite to this is C, so this one is C. And which one is A and B? It doesn't matter. So this one can be A, this one can be B. It doesn't matter. It can be exchanged, and this one is A, this one is B. The result is the same. Okay, so we can write cosine C is really angle C. So we write cosine C equals to, remember these two adjacent sides corresponding to this angle first. So a squared plus b squared minus c squared over 2ab. If we already learned ABC, if you didn't write down ABC, you can just write down the number. So this is 6 squared plus 5 squared minus 7 squared over 2, 6, 5. Okay, now we can calculate this. So 6 squared plus 5 squared minus 7 squared equals 12 over 2 over 6 over 5, which is 0.2. So cosine C is 0.2. That means cosine C is positive. So in S4 we have learned there are two equations to make the value of cosine to be positive, isn't it? So remember, all students take Chinese A and C. That means the angle here and angle here. So the angle here is an acute angle. However, the angle here is a reflex angle. In any triangle, the angle in any triangle will not be a reflex angle. So we should not consider it. You don't have to calculate this one. This one is just calculated from your calculator, the acute angle. That means the reference angle. So you can just calculate. So we can just solve cosine. So 78.463. So angle C is 78.5 and correct to 3 SF. And we should write more digits here, 70x.463. We will use it later. Okay? So now we have already solved this angle. So we need to find all angles. We can find A or we can find B. In this case, do we still need to use cosine formula? Well, we can still use cosine formula. Okay, this case we cannot use cosine formula. Okay, actually you can use, but you can use the sine formula. Okay, although there are SSS, we can use cosine formula to find this, but you don't have to. So we can use sine formula now. Because do you remember in sine formula, 7 and this angle are parallel. So we get this, we can use this side to find this angle. So 5 over sine angle CAB equals to 7 over sine 70x.463 degrees. Sine angle CAB, how to compute this formula, how to write? So we can multiply these two divided by 7. Okay, sine 70x.463 times 5 divided by 7, which is this. That means angle CAB, sine angle CAB is this, so we can solve this angle by sine. So 44.1. So the reference angle is 44.4153 degrees. So for sine positive, if sine is positive, which two quadrants? So it is A and S. So do we need to find the angle in quadrant 2? This is obviously an obtuse angle. Remember, for the longer side 7, the angle is 30x on 30x something degrees. So for the shorter side, will the angle be obtuse? That means will the angle bigger than this angle? No, because the shorter the length, the smaller the angle. So this angle must be less than 70x degrees, but not an obtuse angle. So in this case, we reject this case. We don't have to write down the angle on this quadrant. We just write down this angle. So this angle is just the reference angle. So the answer is 44.4 degrees. Okay, 44.4 degrees. We take more digits as this. So we have get this angle and this angle. So how to find this angle? Do we need to use cosine formula? Do we need to use sine formula? Actually, no. We can use angle sum of triangle. So angle CBA is just 100 degrees minus angle CAB minus angle and ACB. So the answer is 57.1 degrees. So the first angle, angle C is 78.5 degrees. Angle B is 57.1 degrees, and angle A is 44.4 degrees. Okay, here is the fourth example. So, in this figure, find the length of BD. Find the angle BCD. Find the angle CBD. So, part A, which method you will use to find this sine? Okay, yes, we can use sine formula. So part A finished. Okay, part B. What method you will use to find this angle? So do we have the parallel? That means the sine and its corresponding angle, for example, 7.7 cm. Do we have this angle? No, we need to find it in part C. So 3 cm, do we have this angle? No, we don't have. So can we use sine formula? No, we cannot use sine formula. So we have one side, two side. Do we have this side? Yes. In part A, we have already get this size. So S. In a triangle, if we get three sides, S, we can use cosine formula to calculate any angle. So if we want to find this angle in part B, this one is angle C. This is A, sine A, this is sine B, this is sine C. So we can use cosine formula. So we want to find this angle, so cosine this angle, DCB, which is equal to 17.7 square A square plus B square minus C square. This one, don't use this one, we use this one. So after calculate, we get this answer. It's approximately 0.556390. So for cosine positive, all students take Chinese. So in a triangle, we don't have reflex angle, so we check it. So only this answer. So we just shift cosine on this. Okay, the answer is 56.19 degrees. Okay, now we look at part C. We want to find this angle. So, I have written down the answer on the figure. In this case, can we use cosine formula to find? Or can we use sine formula? So we can see that 3 is the shortest line, 7.7 cm is the longest side, and 6.53 is the middle one. So we get the middle one is corresponding to the angle 56 something. If we want to find this angle which is correspond to the longest side, is this side obtuse angle? We are not sure, because for the shorter side 6.53, the angle is 56. This angle can be any angle bigger than 56. It can be an acute angle, it can be obtuse angle. So there will be two possible cases. But if we use cosine formula, there will be only one case. So in this case, in order to avoid too many possible answers, we should use cosine formula in this case. So in part C, we choose to use cosine formula. So we want to find cosine angle CBD. So this sine square plus this sine square first, and then subtract this sine square. Okay, we use this one. So this is the first time we get this answer. The answer is negative. This one plus this one is smaller than 7.7 square. This one is a negative number. So which angle makes cosine theta negative? All students take Chinese, not science. All students take Chinese. Okay. All positive. Sine positive, that means cosine negative. So this angle. This is impossible for a triangle. Okay, just look at these two quadrants. So in this case, if cosine is negative, the angle must be obtuse. Obtuse. This one. So the answer should be 180 degrees minus reference angle. So angle CBD is 180 degrees minus the angle. So in the calculator we see that cosine angle CBD is approximately negative 0.196792. So we need to shift cosine with positive, remember, positive number. Okay, we get this answer. So the reference angle is this one, 78 something. So the angle here is 180 degrees minus this reference angle. So the answer is this. So please do this question at home and we will check the answer in the next section. Okay, please do questions 13, 14, and 15. And question 23 and 24.